Planet X. Specifically, Marshall Masters claimed that Planet X is visible on a webcam located at the Turrialba volcano, and you can see it circled in red here. Now, this video is from 2013, but Masters has been making the circuits again. In fact, he's going to be on Coast to Coast AM again tonight. And he's recently said some rather unkind things about my friend Daz the cameraman. So we're going to see what we can do here, perform an actual orbital analysis. This video is called Planet X System Observations and Orbital Analysis, and he claims that this is a planet located somewhere beyond Jupiter out there in the solar system. So we are going to perform an orbital analysis of this so-called object and see what's what. Now, Daz has recently done some videos on this and has shown quite conclusively that it is in fact a lens flare. You can see it in front of clouds at times. Now, with these images, Masters specifically picked these because the way that the sun set made it look like this was actually going behind the clouds that day. You can see as the sun approaches the clouds, it starts to go behind the clouds. You can see the glare from the sun is reduced in size quite a bit, and at that time, the lens flare was right above the cloud tops, and it too was shrinking because the sun was also going behind the clouds. And then in the very next frame, the sun is completely behind the cloud tops, and of course, the lens flare is gone. Now, that, if you just look at that on its own, it does look pretty convincing, like a real object going behind the clouds. But that's not the whole picture. There are other images from other days where you can clearly see the same lens flare in front of clouds or steam from the volcano. So here's a day, May 12th from 2013. Look at that. You can see it in front of the clouds. And let's see. Occasionally the sun itself gets blocked out by some of the steam in the clouds, and you lose sight of the flare. But at other times, look at that. The sun is unobstructed enough that we can see the flare straight through all the steam and clouds and everything else. It's just dependent upon how obstructed the sun is or isn't, as the case may be. There it is again through some clouds, more clouds. Oh, look at that. Look at that. Thick clouds, and it's still perfectly visible. So it's clearly a lens flare, but that's okay. Let's just assume for a second that it isn't. Let's assume for a second that Masters is right, that somehow this is Planet X visible on this webcam. So let's do an orbital analysis on it. Well, how are we going to do that? Normally, we would perform some astrometry relative to the stars, but there's only one star visible in this picture, and that's the sun. Unfortunately, the sun is massively overexposed, so we can't calibrate the image based on the size of the sun because we can't actually see the sun's disk. We just see this overexposed glare. But what we can see is the sun's motion over time. So as long as we know when the images were taken, and they do have these handy date stamps on them, we can figure out what the image scale actually is. And that actually works out to about 0.035 degrees per pixel. We know where the sun should be from the Turrialba volcano, and we can see where it is in the images. It's at the center of this glare. So we can figure out how quickly it's moving, and therefore what the image scale is, as well as the orientation of the image, where it's pointed. We know what the altitude and azimuth of the sun should be at these various times, so we can figure out where this image is actually pointed. And if we plug all that in, we can actually figure out the altitude azimuth as well as the RA, the right ascension, and declination coordinates for any given point in the image, as long as we know when it was taken. And we do know that. Again, we have these handy date stamps right on the image. So what I've done is I've created a spreadsheet that will allow you to plug in the time in universal time. Now keep in mind that these images are taken at 6 hours behind universal time, so you need to add 6 hours to whatever the time is here to get universal time, and plug that in. I've already got the location of the volcano plugged in, and then you just plug in the coordinates of the object in the image, and it will spit out the altitude and azimuth and the right ascension and declination. Now these fields here are at the equinox of date, the date of observation. But I've also included additional calculations that will process them back to J2000, the standard J2000 format, so that you can plug them into any standard program and calculate an orbit for it, or at least try to, and therein lies the problem. So first of all, right ascension, hours, minutes, seconds, and then declination, degrees, minutes, seconds. From that, you can create a list of observations over the period of time where you can see this so-called Planet X object. And from that, we can try to calculate an orbit. Well, FindOrb, despite everything, cannot find any orbit that describes the motion of this object. The motion of this object does not match any kind of real object in space. It does not move like an actual celestial object in our solar system. It just yields nonsense data, just not a number, NaN, that's what that stands for. It can't find any orbit for this at all. Well, that's disappointing. I mean, it makes sense. It is a lens flare, but it'd be nice if we could find some sort of orbit right? I mean, that's what we're after here. We're assuming for a second that this thing really is Planet X. So let's thoroughly investigate this as hard as we can and see if we can't find some sort of orbit for this. So let's try another program. Let's try LFind. All right, so LFind wants to try to find an orbit based on 2 or 3 observations. For 2 observations, it will simply assume a perfectly circular orbit. For 3 observations, it will be able to find eccentric orbits. So more the better, but also the longer time span, the better. The more of the orbit you cover with the observations. So let's pick from the beginning and the middle and the end of the observation period, which covers about 2.5 hours on April 23rd. And you can see the coordinates here for each observation, right ascension over here, declination over here. Let's pick 1, 4, and 7 and see if we can find an orbit with the LFind program. Nope, once again, no orbit found. It's just non-real numbers. It can't find any orbit that would match these observations. All right, well, let's try a short arc. Let's try just a few minutes of time and see if the motion of this so-called planet X can match an orbit at least over very short periods of time. So let's just try a few minutes span of time, just the first 3 observations, 1, 2, and 3. Oh, there we go. Now we have an orbit. All right, let's try 2, 3, and 4. Observations 2, 3, and 4. We have another orbit. All right, let's try 3, 4, and 5. And we have yet another orbit. And notice these orbits are not quite the same. Well, that's okay. We're going to try 4, 5, and 6 and see if we can get some agreement on what the orbit should be, or really is, of this object. All right, let's try 5, 6, and 7. All right, so now we have all these different orbits, all slightly different, but maybe that's just because of looking at such short arcs of time. We're only looking at a tiny piece of the would-be orbit over just a few minutes of time with each set of 3 observations. So maybe we need to look at all these orbits together and see if they have something in common with each other that might tell us where this planet X really is located, right? So we're going to load these orbits into ORSA and take a look at them. Now I'm going to make the images here from April 23rd available in the video description in a zip file. I'll also put the spreadsheet here into the video description as a link so you can download that and try it yourself. And it will yield the coordinates that you need to do these calculations yourself, and it will give you coordinates that are accurate to within a fraction of a degree. And I was able to confirm that by also checking the sun's position at a later date and seeing if it matched up with where the sun should be, and it did to within a fraction of a degree. So the spreadsheet's working good here, and now we have some orbital data we can look at. So let's see what these orbits might have in common.
All right, so here we are in ORSA. Now we're going to take a look at the orbits we just calculated with LFind and see what the orbit of this so-called Planet X object really looks like. Now remember, according to Marshall Masters, it's somewhere out beyond Jupiter, or at least it was at the time that it was seen at that volcano, but it's not there. You have to zoom in much closer to Earth to see it. You can see Earth and the Moon there. You have to go closer still, and here we are. Each one of these are one of the orbits that we just calculated with LFind. I've labeled them A, B, C, D, and E. And as you can see, they all do have something in common. They are all Earth orbits. Now, as I showed before, FindOrb couldn't find any solution. FindOrb is designed to find objects beyond Earth orbit somewhere in the solar system, anywhere in the solar system. You just feed it the astrometric data and it gives you the orbit. Well, it couldn't find an orbital solution. LFind could, but only if it looked at a few minutes at a time. If you looked at the entirety of the observational period, it couldn't find anything either. But if you look at just a few minutes at a time, what you find is that it approximates an Earth-orbiting satellite. Well, sort of orbiting. Some of these are actually suborbital trajectories. You can see here how the line intersects Earth's surface, and this one as well. And if we look at a graph of the perigee distance, pericenter with respect to Earth, in some of these cases, it's less than Earth's radius, 6,371 kilometers. We see that's the case with E, and we see that's the case with object A. This one's much less than Earth's radius. And so this would be a suborbital trajectory. It wouldn't last very long as an object if it really were out there. But it's not. It's just a lens flare, as Dazza showed. But if it were really Planet X, then that would mean Planet X is actually a moon of Earth. And there's the orbital data to prove it. So that's the orbital analysis on the Turrialba webcam. And I hope you all have a nice day.
Hi folks, Astronomy Live here. Today I'm going to be talking about Planet X. Specifically, Marshall Masters claim that Planet X is visible on a webcam located at the Turrialba volcano, and you can see it circled in red here. Now, this video is from 2013, but Masters has been making the circuits again. In fact, he's going to be on Coast to Coast AM again tonight. And he's recently said some rather unkind things about my friend Daz, the cameraman. So we're going to see what we can do here, perform an actual orbital analysis. This video is called Planet X System Observations and Orbital Analysis, and he claims that this is a planet located somewhere beyond Jupiter out there in the solar system. So we are going to perform an orbital analysis of this so-called object and see what's what. Now, Das has recently done some videos on this and has shown quite conclusively that it is in fact a lens flare. You can see it in front of clouds at times. Now, with these images, Masters just specifically picked these because the way that the sun set made it look like this was actually going behind the clouds that day. You can see as the sun approaches the clouds, it starts to go behind the clouds. You can see the glare from the sun is reduced in size quite a bit, and at that time, the lens flare was right above the cloud tops, and it too was shrinking because the sun was also going behind the clouds. And then in the very next frame, the sun is completely behind the cloud tops, and of course, the lens flare is gone. Now, that, if you just look at that on its own, it